Hi there, welcome to your video tutorial on regression, logarithmic, and exponential. So as we just discussed, there are these four main types of curves you should be very familiar with. Exponential growth, exponential decay, logarithmic growth, and logarithmic decay. Lots of real-life data will follow these kinds of patterns of behavior, and it is your job to look at data and determine which of these graphs, well, basically exponential or logarithmic, will be the best model for certain data. So we're going to look at the idea of bacterial growth in a Petri dish. And here is your data. All right, this is on the back of your worksheet. This shows number of bacteria cells in a Petri dish, which is represented with the y variable, dependent on the number of days after the sample was introduced. So this is the number of days after the first sample was introduced to this Petri dish, and then it grew and grew and grew. So let's see what we can do with that. Let's use our GDC and Desmos at the same time to put this table in. So I'm going to do it on GDC first. Get your GDC ready. So on your GDC, anytime you need to enter a list of data, statistical data, you press the Stat button, press Stat. Then you go to the Edit menu, number 1. That takes you into this table. Right now I have data in there, so I'm going to clear it out. To clear a list, you go on top where it's on list 1 or list 2. You press Clear, and then enter twice. Okay, now let's go to the other list. I'm going to clear the second list. Go up to where it has list 2. Press Clear, and I'm going to clear out that list. So now I'm going to fill the list with the data I have. I have 1, 2, 3, 4, 5, 10, and 15. So I'm going to put those values in. 1, 2, 3, 4, 5, and then it jumps to 10 and 15. Okay, 10 and 15. All right. Now I'm going to go to list 2 and put in the y values, 19, 23, 30, 19, 23, 30, 35, 42, 89, and 253. Great, now I put my data in. Now to graph or plot the data, I have to make sure that my stat plot is on. So you're going to press second, y equals, which is stat plot. And you're going to look at your first one here, number 1. Mine is on, but in case yours says off, let me show you how to turn it on. So you're going to press 1. And here you have on or off. So make sure if yours is on off, you go to on, press enter, and now it's ready to go. I'm going to press graph, and it should graph my statistical data. But I see nothing. Sometimes your window isn't set correctly. So let's go to zoom, and we're going to zoom in on this list of zoom features. I'm going to go up to the top. Oh, too much. Number 9. Let me see if I can find number 9. Alright, there's number 9 in the middle. Number 9 is zoom stat. So your window is going to zoom in on all the statistical data you've put in. So it's going to zoom in around the data I put into my table. So I'm going to press 9. Alright, there's my data. Look at that. Now I look at that data and I look at it and I think, now, is this growing exponentially? Is it logarithmic? Well, you can kind of see the basic shape to it. It goes like this and then goes up. Alright, so the graph that models that, like that, kind of going up. Let's look back at our graphs for a second. Which of these does that look like? Well, it's definitely this one, exponential growth. Okay, it's important to choose one. So let's go back to here. This is exponential growth. So now I'm going to do something called regression on the calculator. So I'm going to press the stat button again. Go to calc, so you have to use the arrow, calc. And in calc, there's all these different regressions. You can see here lin regression, which is linear regression, quadratic regression, cubic. Basically what regression is finding an equation that best fits the points in a data set. So ours looks like an exponential growth, so I'm going to go down the list and look for exponential regression. There it is, EXP regression, exponential regression. I'm going to select that one, and it's asking me where am I getting the data from, list 1, list 2, yes, it's taken from both lists, and I'm going to hit calculate. It's going to give me the best regression model for my data. So here's the regression model in this form, y times b, y equals a times b to the x power. That's definitely exponential. Tells me an a value and a b value. That was going to make my data match my data. So a value is 16.5, let's say, if we round it there, and this one is 1.2, let's say. That's close enough, 1.2. So 16.5 and 1.2. So if I go back to here, I'm going to do an insert. You're going to do the same thing when you do your, as a group, you're going to have a problem. You're going to do it in Google Slides. You're going to have to insert a formula as well. That's what I'm doing here. Insert object, and I'm going to do equation. Might be a little different in Google Slides, but you'll figure it out. And my model is in this form. It told me it's in this form, b to the x power. But then it told me what my a and b values are. So let's see, what are my a and b values? It was 16.5 and 1.2 when I rounded. So y equals 16.5 a to the power 1.2. No, that's not right. What am I doing? Sorry, it's an exponential. So that's your exponent is a variable, but my a value, the base, is 1.2. Okay, so you're used to exponentials just looking like this, but sometimes they have a multiplier in front, right? That's something that stretches it vertically, right? Anyway, there's my model. I'm going to go like that. My model has appeared here. Now that I have a model, I can enter into my calculator and see how closely it matches my data. I'm going to go back to Desmos and do this as well. So let me show you how to do this on Desmos. On Desmos, to enter a table, you hit here with the pluses. And you're going to need to do this table when you do your group assigned problem as well. Here's my table. So it's 1, 2, 3, 4, 5, 10, and 15. And here the values were 19, 23, 30, 19, 23, 30, 35, 42, 89, and 253. Okay, I can't see many of those points because my window is not right. To adjust your window, you're going to go here. And here you can set your x values. My x values are, I need to go to 15, right? So it needs, from -1 is fine. It needs to go at least, I'll go 20. And then my y values, those are these values here, they need to go from 0 all the way to 250. So this is fine, and all the way to 250. So let's just say 260. Alright, so there I can see my points clearly now. Maybe I'll set it a little bit higher here, because I can barely see the last one. I'll do 270. Okay, so there's my points. Alright, now here I can enter my model. The model I got was 16.5 times, what was it, 1.2? 1.2 to the power x. Alright, look at that. So there's the model that appeared, and looks like the regression model that the calculator created is very close to the data. It's a very good fit to that data. See how it almost matches the points exactly? It's not perfect. These are a little bit above and below, but very good match to the data. So good regression. Now you can enter the same one on your calculator. So actually for your group project, you're going to have to take a screenshot of your work here. Now for the calculator, I can enter in the model as well. So I'm going to go to y equals. I'm going to put the model in here. So 16.5 times 2, nope, not 2, 1.2, 2 to the power x. Here's my model. Graph that. And you'll see how close that model, it should, just like on Desmos, it should match the data very well. There it is. It's going through my data points, and looks like it's a very good match. So good regression. I have a model to match this real-life data of bacteria in the Petri dish. Now to finish off, we have to answer the two questions we have. The first question is, if you measured the number of bacteria cells 30 days into the experiment. So when it says 30 days into the experiment, is that your x or your y value? let's look back on our model. The days here are the x value. So we're being told that x is, the x value is 30 because we're 30 days in. So I'm going to go to my model. I'm going to enter in 30 for x. Y equals 16.5 times 1.2 to the power, and I'm entering 30 in for that. And on your calculator, you can get that value, so try that with your group. Make sure you know how to get that value, and you'll have an answer for y. You'll know how many cells there are, how many bacterial cells you would expect for 30 days into the experiment. Now let's try the next problem. This problem says if you found there to be approximately 1,000 cells, then how many days into experiment would you be? So this time we're looking for the number of days. So again, x is the number of days. That's going to be our unknown. And we're told that there's 1,000 cells. So y represents how many cells there are in the bacteria culture. So this time we're going to replace y with 1,000 and set it equal to that. Times 1.2 to the x power. Alright, how do you solve that? Well, first step is to get rid of the 16.5. I'm going to divide both sides by 16.5. So on this side, 1,000 divided by 16.5, 1,000 divided by 16.5, 60.6. I'll just round that, 60.6 equals 1.2 to the x power. Alright, now how do you solve this? How do you solve something where the exponent is the unknown, where you can apply logs of logs, or you can apply log to both sides? That's the technique we learned. So I'm going to do a log of 60.6, and I'm going to apply log to the other side also. Log of 1.2 to the x. I've applied log on both sides. Now I can drop the x down. Remember that rule about bringing the exponent down. So the x came down, and now I can solve for x. So x equals log of 60.6 divided by log of 1.2. And that should give you your x value and should allow you to solve for how many days it would take to get 1,000 cells of bacteria. So try that on your calculator. Let's see what we get. And that's the process for solving these questions. So make sure you agree as a group what the answer is, and now you are going to move on to group project, where you go to Google Slides, and based on which group you are, you will solve one problem the same way. Alright, you can do it. Enjoy, and looking forward to seeing your work.